Hello. In this module, we will discuss importance of fiber optic communication subject in electronics and communication field. For this subject, prerequisite conduct semiconductor physics, electromagnetic, mode theory of waveguide, and analog communication. The rationale required to introduce the student to various optical fiber modes, configuration, and various signal degradation factors associated with optical fibers, and to study about various optical source and optical detector and their use in the optical communication system. Then we discuss optical amplifier, then fiber optic network element, basic optical component, and techniques of fiber optic measurement. This is a teaching learning scheme in this subject, which will cover teaching scheme lecture 3, tutorial 0, practical 2, credit is 4. Examination mark is theory marks, end semester examination 70, and progressive assessment mark is 30. Whereas end semester practical marks, end semester examination 30, and progressive assessment mark is 20. So total is 150. Content. Content covered. First chapter, overview of optical fiber communication. In this chapter, electromagnetic spectrum, optical spectral band, evolution of fiber optical system, multiplexing technique, elements of an optical fiber transmission link with the functional description of each block, WDM concept, transmission windows, advantage of optical fiber link over conventional copper system, application of fiber optic transmission system, which requires a total of 2 and weightage is 6%. The second chapter, that is optical fiber, which include structure, waveguide, and fabrication. In this chapter, optical laws and definition, optical fiber modes and configuration, mode theory, step index and graded index fibers, single mode and graded index fibers, derivation for numerical aperture, V number and mode supported by step index fibers, mode field, numerical aperture, and mode supported by GI index fibers, fiber materials, linearly polarized modes, fiber fabrication technique, and mechanical property of fiber and fiber optical cables are discussed. This content required total number of 6 hours and weightage is 30%. Third chapter about signal degradation in optical fiber. In this chapter, attenuation, signal distortion in optical waveguides, pulse broadening in graded index fibers, characteristic of single mode fibers, mode coupling, international standard for optical fiber transmission is discussed. This chapter contained total number of 5 hours and weightage of this particular chapter is 10%. Then optical source. In this chapter, semiconductor physics background, light emitting diode structure, then material, figure of merit, characteristic and modulation, laser diode, modes and threshold condition, diode rate equations, resonance frequencies, structures, characteristic and figure of merit, single mode laser, modulation of laser diodes, spectral width, temperature effect, and the light source linearity is discussed. This chapter content of total number 4 hours and weightage is 12%. The next chapter 5 is about power launching and coupling. In this chapter, source to fiber power launching, lensing scheme, fiber to fiber joint, light emitting diode coupling to single mode fibers, fiber splicing, optical fiber connectors are discussed. This chapter requires total number of 4 hours and weightage is 8%. Photo detector. In this chapter, principle of operation, types, characteristic, figure of merits of detectors, photodiode, materials, photodetector noise, detector response time, temperature effect on gain, comparison of photodetectors are discussed. This chapter is required for number of hours and weightage is 8%. The next is optical receiver operation. In this chapter, receiver operation with preamplifier types, receiver performance and sensitivity, eye diagrams, coherent detection, and specification of receivers are discussed. Number of hours is 4 for this chapter and weightage is 10%. Next, 8th chapter is transmission system. In this chapter, point-to-point link system, consideration link power budget and rise time budget method for design of optical link ER calculation are discussed. This requires total number of 3 hours and weightage is 6%. Then chapter 9 is optical amplifier. In this chapter, semiconductor optical amplifier, RFID doped amplifier, Raman amplifier, wideband optical amplifier are discussed. This chapter requires 4 number of total hours and weightage is 5%. 10. Advance in optical fiber system. In this chapter, principle of wavelength division multiplexing, then WDM, telecommunication and broadband application, SONET and SDGH, multiplexing, analog and digital broadband, optical switchings are discussed. This chapter requires 3 number of total hours and weightage is 10%. Chapter 11. Overview of optical component. This chapter includes optical coupler, tunable source and filter, optical multiplex and demultiplexer, arrayed waveguide granting, optical add-drop multiplexer, optical regulators, attenuator, optical cross connector, wavelength converter, match gender interferometer is discussed. This chapter requires 3 number of total hours and weightage is 6%. The last chapter includes fiber optical measurement to test equipment, OTDR, optical time diameter, setup for measurement of attenuation, dispersion, numerical aperture and eye pattern that is discussed in this chapter. And total number of hours is 3 is required to complete this chapter and weightage is 6%. This is a suggested specification table with mark in theory for B. Distribution of theory marks, R level means remembrance level is 10, then understanding level 15, application level 10, analyze level 15, evaluate level 10, creation level and above levels are 10. As this is as per revised Blue's taxonomy. This specification table should be treated as a general guideline for student and teacher. The actual distribution of mark in the question paper may vary slightly from the discussed table. Reference book listed as Optical Fiber Communication by Gerd Kaiser, 4th edition. This is a very good book and fundamental book for optical fiber communication. More theory concepts are clear with this particular book. Then second book is Optical Fiber Communication by John M. Senior. Number of examples are more in this particular book. You can also refer Fiber Optical Communication Technology by Myambao and Lowell from the PSF publication and Fiber Optic Communication System by G. Agarwal, John Williamsons. After completion of this course outcome is first CO1 that to understand the basic elements of optical fiber transmission link, fiber mode, structure, configuration, networking, and operating principle of SONET, SDH, and WDM, as well as use of optical measurement instruments such as OTDR. And weightage of the particular weighted CO is 22%. CO2 is to be familiar with the use of various optical components constituting optical fiber links like optical coupler, tunable source, and filter, optical multiplexer, demultiplexer, arrayed waveguide granting, optical add-drop multiplexer, optical circulator, attenuator, optical cross connect, wavelength converter, match-Zander interferometer, and the weight of the particular CO2 is 18%. Then CO3 is to calculate different kind of losses, signal distortion in optical waveguides, signal degradation factors, and dispersion management technique in optical system performance, and compare the various optical source materials. LED structure, photodetector, laser diodes based on their figure of merits. And the weight of this particular CO3 is 30%. Then CO4 include analyze and design of optical fiber link with encapsulation of different system component, and the weightage of this CO4 is about 30%. These are the list of experiment that setting of analog and digital optical fiber communication link, then measurement of attenuation characteristic of an optical fiber, measurement of numerical aperture of a multimode fiber, measurement of mode field diameter of a single mode fiber, then measurement of dispersion of optical fiber, then performance of PAM on fiber optical link, then performance PWM on fiber optical link, then performance and pulse modulation on fiber optical link, the measurement of attenuation with OTDR, the measurement of emission wavelength of LED and laser source, then measurement of data quality with eye pattern, and preparation of optical fiber and practice on splicing and connectorization, performance of TDM on fiber optic link, then setting up a voice link on optical communication link, then performance of experiment on the VI characteristic of the optical source, performing experiment on the characteristic of the optical detectors, simulation based experiment and design using OptiSystem or maybe Scilab. In this case, we have used Scilab. Major equipment, the fiber optical trainer kit, laser source, photodetector, optical power meter, OTDR, WDM trainer setup, splicing and connector kits. These are the list of open source software for training for learning website, that OptiSystem version, NPTEL videos, AICTE Swayamport, and Scilab. Scilab is also useful for complete this practical from the optical fiber communication system. Thank you.